B1 is a real number. X and Y are the points on the x-axis and y-axis, or popularly known as ECC, is the most strongest or most widely used and strongest cryptographic system. We can see the rule of addition in elliptic curve crypto system. Then you can say that minus y is the additive inverse of the y. Hello students, welcome to the next session of Network Security. I am Dr. Soumyashri from Department of Computer Science, Vidhyaashram, first grade college. Let's talk about the last crypto system in this section, that is the asymmetric key cryptography, that is the elliptic curve crypto system. What is this elliptic curve crypto system? How it is used, how it is going to implement, all these things let's know in this session. Alright. So the first thing is the elliptic curve crypto system. Elliptic curve crypto system, or in general or popularly known as ECC, is the most strongest or most widely used and strongest cryptographic system in the network security. One of the disadvantage of the RSA and Rabin crypto system is the set of keys. We have long set of keys which makes it difficult to take the plain text and making it cipher text, because it uses the long set of keys, isn't it? So it has the large key sets, which is a disadvantage in case of the cryptography. Now, the question is, we have to retain the security level as is with the RSA as well as the Rabin crypto system. But the large key set must be avoided. What can we do for this? Is there any method that we can use for reducing the key set, size of the key, but the security level remains the same? So the solution for this problem was given in the popular elliptic curve crypto system. This is the strongest security level or crypto system that is ever used in the cryptography or in crypto system. Okay, it uses the elliptic curves. Don't confuse the elliptic curves with the ellipses. Ellipses is not an elliptic curve. Okay. So, elliptic curve is taking the set of values from x and y direction. Again, ellipse is also there, but usually ellipse is covering the negative as well as the positive radiants of the x and y. It usually will be like this, isn't it? If you have the x and y, x, y, x, y, so the ellipse will be like this, isn't it? So equally distributed over the 4 variants. Now, but the elliptic curve is having range of values distributed over the x and the y axis, making negative or positive. So the values distributed over x and y, it is not exactly the ellipse, it is only the elliptic curve like which represents the ellipse. It is called as the elliptic curve cryptography. Okay. So there are 3 categories by which you can create an elliptic curve. So elliptic curve crypto system deals with 3 different variables. What are those 3 different variables is, it deals with elliptic curve cryptography using over real numbers. Over real numbers, we are going to implement the ECC. Then elliptic curve crypto system over. Second is the elliptic curve crypto system over the set of primes, that is called as the ZP. Elliptic curve crypto system over ZP, that is prime values, and the elliptic curve cryptosystem over the set of finite values over with a range of 2 to the power of n values. We have 3 range of values in an elliptic curve cryptosystem. Cryptosystem implemented over real numbers, cryptosystem, elliptic curve cryptosystem over prime number values, prime values, and elliptic curve cryptosystem over the fixed size variables, that is 2 to the power of n set of values. So 3 different variables are used in the elliptic curve cryptosystem. We make use of the elliptic curve cubic equation. So cubic equation which is used to find the circumference of a circle. So we use the cubic equation. Before that, the general equation for an elliptic curve can be given like this: y2 plus b1 into xy. b1 is a value, b1 is a real number. X and y are the points on the x-axis and y-axis, plus b2y. This is an equation which is equal to x3 plus a1 into x2. If you take two variables, a1, a2, a3, if you take as the 3 variables or 3 points on the elliptic curve or in the x and y direction, so we take the expression x3 plus a1 into x to the power of 2 plus a2 into x plus a3. So there will be diminishing x values and increasing a values. Okay. So x3, x2, x and a. So there will be x to the power of 0, x to the power of 1, x to the power of 0. Diminishing powers of the x will be used along with 3 different variable values a1, a2, a3. So these are the range of values in the curve in a x and y direction will be equal to the elliptic curve equation, that is the cubic equation that is used in calculating the circumference of a circle. So it is y2 plus b1 into xy plus b2 into y. Okay. So elliptic curves over real number uses a special class of elliptic curves which are of the form which I said, the cubic equation. This is the original cubic equation. So it is y2 equals x3 plus ax plus b. This is the cubic equation that is used in the elliptic curve for real numbers. Okay. Now, we have an example of how does the elliptic curve will be used. Okay. So we have a figure which shows 2 elliptic curves. We have 2 elliptic curves here. It is not a mathematical curve. It is representing set of values in the curve like 2, 3, or it is integrating here. We have the values like this. We have set of values in x positive. So you can observe here, x is always positive value we are taking. Only negative values we are taking is y. It may be x and y. So we take the cubic equation here, that is y square equals x cube plus ax plus b. So this is the cubic equation that we have used. X cube, x to the power of 3 plus ax plus b. So when you calculate the value of y, it will be plus or minus square root of x3 plus ax plus b. That means you can have the positive values as well as negative values in a cubic, the elliptic curve. It takes y equals plus or minus x cube plus ax plus b, where a and b are 2 points on the curve and we take the value A and B on the curve. When y is having 3 points over the curve which makes a straight line, then you can take the sum of those 3 points will be equal to 0. If you take this elliptic curve and you have 3 points here, if you have 3 points here which make a straight line over x and y axis, if you have the values like this which makes a straight line of 3 points, the sum of those 3 points will be equal to 0. So y can have some points in the positive quadrant and some in the negative quadrant. Both the things are possible. We take the straight line when you have 3 points which make a straight line. Okay. Here we have 2 elliptic curves with equations y2 equals x3 minus 4x and y2 equals, there is another expression, y2 equals x to the power of 3 minus 1. You can observe a difference of curve here. You can observe the difference of curve here. This is a longer one and is having 3 more points in the x-axis. So we have x3 minus 4x and y2 equals x3 minus x1 minus 1. So both are non-singular. That means they have multiple values. However, the first has 3 real roots. That is the minus 2, 0, 2. X equals 2, x equals 0 and x equals 2. You can calculate y based on these values like y2 equals x3. If you take it as minus 2, it will be minus 8 minus 4 into minus 2. We take minus 8 minus 8. It is 0. Y is equal to 0. And if you take 2, it will be y square equals x cube. It is 8 minus 4 into 2. That is 8 minus 8. Again, y is equal to 0. So all the values y is having 0. That means it is making a straight line with the 3 values. Sum will always be 0. Then we have the second one with only one real root, x equals 1. Okay. And 2 imaginary ones. We can't see the values here. They are imaginary ones. So we have the elliptic curve with the real numbers. Then we have another figure, 3 adding cases in an elliptic curve. We can add 3 values here. You can calculate 3 values here with every elliptic curve. Okay. You can view here. So you can make a point in this. Expression will be r equals p plus q. We are taking 2 points for the curve. Here we have again 3 points. This is 2 points. We are taking p minus r. It is negative value. Then the positive value r. R equals p plus p. We are taking the same value. And this is O equals, it is taking the negative quadrant in x. So O equals p plus minus p. This will become 0. When you have p plus minus p, the value will become 0, isn't it? So we have the example of the elliptic curves in these 3 different cases. So we have the addition cases in this. Let's see the rules of the addition in the elliptic curve crypto system. We can see the rule of addition in elliptic curve crypto system, which uses only using the real numbers. What are the rules of addition? The first rule is the curve 3 points will be joined by a straight line. 3 points on the curve, if they are joined by a straight line, the sum of the 3 points will become 0. Now, when the sum becomes 0, 0 acts as an identity value. So, it can act as an identity value. Third rule of addition is, if P has 2 points xp and yp on x and y direction. P is a point on the curve. Curve usually has an x direction and y direction, isn't it? If P is equal to xp and yp, the negative P, that is minus P, will take only the y coordinate. Only negative quadrant of the y coordinate will be considered when the point on the curve is connected with the negative value. If P becomes negative, only negative quadrant of the y direction will be considered. X remains the constant. So, this is a elliptic curve with the real numbers. Okay. Here we have the expression for the elliptic curve. We have the expression here. Lambda equals y2 minus y1 divided by x2 minus x1. x3 lambda square, x3 into lambda square minus x1 minus x2. So, these are the expression we can give for the elliptic curve. The intercepting point will be at infinity. We don't know when the x direction and the curves will intercept or y direction will intercept. A point 0 as the point at infinity or 0 point is considered, which is the additive identity of the group. As I said, if 3 lines are considered in a straight line, intercepting point at the intercepting point in the diagram, when you have 3 points in a straight line with the intercepting points, the sum of these 3 will be equal to 0 and are called as the identity of the group. Okay. Next we have the elliptic curves over the set of prime numbers. The first one was related to only real numbers, whereas the prime values are the next case where elliptic curve systems will be executed. In this, we have to find the inverse for the prime. Okay. So, inverse of a point xy is x minus y. As I said, it will always be changed in the negative quadrant of the y, not the x direction. Okay. Where minus y is the additive inverse of y, because y plus minus y will become 0. If it happens, then you can say that minus y is the additive inverse of the y. For example, if p equals 13, the inverse of 4, 2 is 4 and 11. So, we have the additive inverse. 4 and 2 will be, 4 remains the same, 4. So, this will be 13 minus 2, that is 11. P minus B will be taken, P minus B, which acts as, which takes the result 11. Okay. So, this is the additive inverse which we can calculate over the set of primes. Okay. How do you find the points on the curve? Now, the next thing is finding the points on the curve. How you are going to find the points on the curve? We have an algorithm which shows the pseudocode for the points on the curve P of A, B. Let's see the algorithm. Here we have the pseudocode for finding the points on an elliptic curve. What are the points we need to consider? So those points will be considered for the ciphertext. Okay. As we know, the asymmetric key cryptography deals with the numbers rather than the alphabets. In numbers, we are dealing with the real numbers, primes, and 2 to the power of n numbers. Okay. So we have the points to be founded on the elliptic curve. We have the elliptic curve points with the parameters p, a, b. Here we have x is initialized to 0. X will always be constant with any elliptic curve. While x is less than p, x is considered as less than p. X starts with the 0 and is considered as less than p. P is point on x and y direction. So we will be calculating the w intermediate points. If w is a perfect square in ZP, ZP is set of primes. Okay, P stands for primes. ZP is the set of primes with P as the presentation, or P you can take, or A and B. P is the set of primes. What you have to do is x3 plus ax plus b mod P. The cubic equation will be modified like this. Y square mod P is equal to x cube plus ax plus b mod P. Here P is the set of the primes. The equation, cubic equation in case of primes will be considered like this. So we have W is equal to x3 plus ax plus b, that is the cubic equation that we use, which is modulus operation is done by the set of primes. Okay. If W is a perfect square in set of primes, output will be x comma square root of W, x minus x comma minus negative of square root of W. W is the perfect square, or checking the perfect square. If it is a perfect square, so x will be incremented. Okay. So this is the pseudocode that we can use for an elliptic curve generation over the set of prime numbers. Okay. So the equation we use is y square equals x cube plus x plus 1, and the calculation is done with modulo 13. We use the modulo 13 and the additive inverse of 13. So we have points on elliptic curve over primes. We have the P 0, 1, 0 minus 12, that is P is equal to 13. So we take the additive inverse of P. P are the several points like 0, 1 over the x and y direction, 0, 1 minus P will be 0, 12. Here we have 0, 12. So negative point will be considered, 0, 12. So we have the 1, 4. The additive inverse is 1, 9. Then we have 4, 2. The additive inverse is 4, 11. So like this, these are the points on an elliptic curve over the finite set of primes. GF is nothing but a finite set which is discovered by or invented by a scientist. So it is named with the scientist name with a popular name known as GF set of values. So finite set of values will be prime set of values will be taken, and we use the points to find out the location of the elliptic curve. How? You have to draw the elliptic curve. Whether there is a straight line that can form, all things will be considered in a graph. Okay. Let us add 2 points with the previous example as R equals P plus Q. We had P. Now we are adding another point. It is Q, where P is equal to 4, 2 and q is equal to 10, 6. We are adding two values. Okay, we consider the expression lambda equals 6 minus 2 into 10 minus 4 to the power of minus 1. So we consider this with mod 13. We get 4 into 6 to the power of minus 1 mod 13. That is the 5 mod 13 we use. Okay. Then we use other 2 points x and y on the curve or on the graph to form or to find out the 3 points on the curve. Okay. Next thing is the elliptic curve over the set of finite values. The values will be the set of 2 to the power of n. N may be 0, 1, 2, 3 like that up to n values. So the set of finite values with 2 to the power of n values. That is finite set of 2 to the power of n values will be considered for creating the elliptic curves. Now let's check for the elliptic curves on 2 to the power of n set of values. To define an elliptic curve over set of 2 to the power of n values, you need to change the cubic equation. Okay. So the common equation that we use with the cubic equation is, the modification is y square plus xy equals x cube plus ax square plus b. We are adding extra x points to the cubic equation, which helps in creating the elliptic curve over an axis. Okay. So the thing is, we have to find the inverse. We have to find the inverse with, if p equals xy, then minus p equals x comma x plus y. So the additive inverse for the points xy over p is x comma x plus y. Then the next thing is how to find the points on the curve. Okay, we can write the algorithm, an algorithm to find the points on the curve using the generators for polynomials. We use the polynomial generator, and we can use the values for finding the inverse, that is x of y. Then minus p will be equal to x comma x plus y. We can have an algorithm for finding the points on the elliptic curve. Let's check an example here. We take a value, choose a set of values 2 to the power of 3 with elements 0, 1, g, g2, g3, g4, g5 and g6, which are the irreducible polynomial of f of x, which cannot be reduced. And the expression we use for f of x is x3 plus x plus 1. So we use the irreversible reducible polynomial f of x, which means that g3 plus g plus 1 is equal to 0. As I said, the points on the same straight line will give the sum 0, or g3 equals g plus 1. If you take to this RHS side, this will become g to the power of 3 is equal to g plus 1. Other powers of g can also be calculated by using this expression. Okay. Accordingly, the following shows the values of the g's. Okay. G cube equals g plus 1. So the 0, we have the points, all the zeros, which will be calculating. G3 will be calculated to 0, 1, 1, g plus 1. Then we have 0, 0, 1, that is the numeric binary 1 with g to the power of 4 equals g square plus g. So we take the irreducible polynomial. It is giving the value 1, 1, 0. Then we have the g with the value 2 or 0, 1, 0, binary 0, 1, 0. The expression we get is g to the power of 5 equals g square plus g plus 1. We can calculate the triple 1. Next is 100 or binary 100 or decimal 4. Now we have g6 equals g square plus 1. This is the expression we get, and the values we get for g6 is 101. So we get g3, g4, g5 and g6 can be calculated by using these expressions. Okay. Using the elliptic curve, y square plus xy equals x3 plus g to the x to the power of 3 plus g to the power of 3 into x to the power of 2 plus 1 with a equals g to the power of 3 and b equals 1. So you can find the points on the curve as it is shown in the figure. Okay, points on the elliptic curve over the 2 to the power of n is 0, 1 gives the minus p, 0, 1 only. So we take g, g2, g3 up to g6, set of 2 to the power of n. If it is g2 comma 1, we have g2 comma g6, inverse of it will be calculated. We have the set of values, the positive and the additive inverse of the values will be calculated here. 0, 0, 0, 0 we take. This is the graph we get with the set of values. Okay. If you add 2 points, adding 2 points will calculate if p equals x1 comma y1, q equals x2 comma y2, where q is not equal to minus p and q is equal to p, then r will become x3 comma y3 equals p plus q. So x3 will be replaced by p and y3 will be replaced by q. It can be found as using this expression. Okay. If q equals p, then r equals p plus p, that is 2p we get. R equals 2p, that can be found using these expressions. Okay. So this is about finding the elliptic curve using a cubic equation. All the 3 methods for elliptic curve for real numbers, elliptic curve for set of primes and elliptic curve for set of 2 to the power of n values, all uses the basic cubic equation which calculates the angle of the ellipse. Okay, elliptic curve is not the entire ellipse, it is the angle of the ellipse. So angle will calculate the points which intersect with the x and the y axis. So those points will be taken as the numbers. Those numbers will be used as the ciphertext which will be given to the sender. We will generate a key. So there will be key, points will be generated are used as a key, p into q. You know about the expression n equals p into q, isn't it? So elliptic curve cryptosystem will calculate p and q using these 3 methods with real numbers, set of primes and the set of 2 to the power of n values. So p and q will be calculated, which acts as the private key. Using p and q, we can calculate the n, which acts as a public key. So public key will be propagated or transmitted over the key distribution channel, which sends the public key to all the senders. Sender will send the calculate the ciphertext and will send the ciphertext to you. Using the set of values p and q, using the elliptic curve cryptosystem method, we can get the plain text by using the ciphertext. Okay, so this is how you can use the elliptic curve crypto system. This is the, as I said, this is the strongest crypto system that we can use only with few sets of keys. So these are the methods that we can use to get a key. These are the all the expressions that we have shown, all the points that we have shown are the set of keys. As we know, RACA in Rabin has long set of keys or large keys. So to avoid that, we have this curve. The points on the curve make up the keys in the elliptic curve crypto system. Okay, so this is all about the crypto system in asymmetric key cryptography. In the next sessions, we shall know about some of the mathematical things, how we can calculate the cryptographic points, okay, or the keys. All right. Thank you.